Next speaker is Jim Keravala. He's the co-founder and chief executive officer of OFFWORLD, building an industrial robotic workforce to undertake mining, manufacturing, and construction on planetary surfaces and in space. The workforce performs a solar system platform that will enable the construction of space-based solar power stations, propellant depots, and entire settlements. He brings 30 years of experience in visionary leadership and innovation in multidisciplinary areas such as aerospace engineering, space systems, robotics, and machine intelligence, manufacturing, construction, computer science, synthetic biology, and molecularly precise control systems. He doesn't seem to be able to focus. Jim's a prolific technologist and an accomplished entrepreneur, able to constantly identify new acceleration ramps in the technological landscape. He started his career in the space launch industry, managing launch programs, overseeing over a dozen successful orbital launches on Russian, European, and US launch vehicles, modular satellite design, integration, engineering, program management part of this process. He also architected major space programs, including new space agencies and launches at Surrey Satellite Technology, and is co-founder of Shackleton Energy.
Let's cut it there, Rand. I'll dive in.
Yeah,
Thanks a lot. Hi, everyone, and thanks for the opportunity to participate in this extraordinarily great collection of presentations and folks. So OFFWORLD is building machine intelligent robots to operate on all celestial bodies in free space to undertake heavy industrial tasks in mining, infrastructure repair, construction, and other aspects. The goal being to ultimately build civilization out into the solar system and beyond. Our three underlying principles are to have a total life insurance policy for humanity, to sustainably develop life on Earth by using the resources of space, and of course, just to open up the frontier. Now, moving out into new domains has always been hard. In space, it's even harder. There's no atmosphere, no gravity that we're used to, and a whole bunch of other effects for our machinery systems and biology. In order to lay the underlying infrastructure, we can't use people at the front end, of course. We do need machines, but we also need to separate the agency of decision from the operation of implementation. So we need autonomous, thinking, collaborative machines. But we can't just export technology that we built on Earth. We need a new paradigm in industrial process. We need to break the last 10,000 years of slave and forced labor and create a new workforce that can autonomously collaborate together and build for the future. And we also need, in the space mining and space business sectors beyond geostationary orbit, we also need to be clear about what is our vision model and what is our business model. We need to be able to separate those two out and understand how we hold to our vision whilst maintaining operations in pragmatic business operations that allow us to build forward. And as a quick mining space business mining 101 for the young folks and not so young folks listening in today, I would recommend the following. Find the planet with the most customers and start there. Build a great team and focus on something that can generate revenue from the start. If we can't get all the way to the moon initially, it's fine to choose an orbital services capability. But be clear about what you want to do at the end of your entire vision. I think it's very important to generate revenue as you go along, if you can. That consolidates your business model and adds credibility. And don't try and just aim for market sectors. Be cheeky and relentless and get customers. Even if it's for MOUs or LOIs, even paying customers, try and secure customers first. And I think the most important lesson for this decade is optimize for cost to service, not mass to orbit. The era, hopefully, of launch vehicles being priced on mass will come to a close this decade, and we'll enter a new paradigm. And I think Rand is going to tell us more about that in the coming weeks and months with some new articles. And establish lasting differentiation. It doesn't mean anything to be first to market. It's who's going to stay in the market, who stays in the game. So the chasm is reducing, and the era of space resources businesses is upon us. And so from our side, we took some of the lessons learned from the robotics era and built a new universal platform of hardened mobile industrial robotics that have modular subsystems in the context of mobility, thermal, tooling, articulation, manipulation, sensing, and other functions, and can extend the initial platform that we developed for the mining industry into multiple sectors. We're also expanding into undersea operations for plastics remediation and into space for space debris and lunar mining operations. The principles we're operating by from our engineering architecture is to reduce the cost of operations by an order of magnitude with fully scalable solutions that can basically turn conventional industrial processes on their head. And we took our context of what would be the ideal operation for infrastructure building in space, and it would be to have no fixed infrastructure to support that build, no people present or astronauts present to monitor machinery in situ, leave no environmental footprint, and minimize the use of consumables where possible. And when we brought that capability down to Earth, it allowed us to develop an architecture of a new industrial robotic workforce that can really cut CapEx and OpEx for terrestrial industries. So these are some folks on the planet, first planet we're operating on, undertaking 19th century tasks in the 21st century, which we really want to replace with these systems going forward. And that allows us to build a new architecture of collaborative systems that can be operated remotely, that can think for themselves. And as the machine intelligence evolves and improves over the years, the level of supervised autonomy will reduce to the point where it's basically curated supervision of that autonomy. And at Off-World, we've built our space program here on Earth already, and just engineer the deltas for in-space and celestial body environments. So we built the full stack from hardware, operating system, to tooling, to machine intelligence, and other aspects around this platform architecture that allows these machines, for example, here operating autonomously, to figure out the best locations of chisel excavation on a rock face. And the amazing thing about this is that when you take this approach, you can build a modular architecture that you can configure for any application and task in any sector and industry, because now the delta for your rebuild and new market penetration is minimized by an order of magnitude. The important thing operating in space for hardened industrial processes is that you need robustness across the board, both in the hardware, in your operating systems, in your sensing, and even in the communication and decision making. These systems need to operate 24/5/7 so that we really have a business and revenue generating model that works. And a quick aside, the space resources business is going to be a tricky game. Things are changing rapidly, and for you young folks out there, listen to what many of the old folks like me are wittering on about, and then be prepared to override and adapt and upgrade the thinking. Because, for example, what we have here, the challenge that we have here is that the propellant business for, in say, low lunar orbit here may have been completely uncompetitive for Earth-based propellant with fully expendable launch vehicles, but with fully reusable launch vehicles, in low lunar orbit, if you see on the bottom here, with fully reusable launch vehicles, ISRU is still more competitive, but it's not a big difference, and it gets even worse in low Earth orbit. So in low Earth orbit, with fully reusable launch vehicles, the competitiveness of lunar ISRU is pushed back significantly comparing with fully expendable launch vehicles. So a lot of the assumptions I've made in the past were assuming an inelastic launch pricing and fully expendable launch vehicles. But as I look deeper into this, we're in a moving target game here. And that means we all of us in the industry are going to have to think harder and build further downstream services and products beyond simply accessing ISRU resources. We need to add value to be competitive and to not lose this market gap opportunity. And so make sure that we're building for the future, and that we're prepared to be competing against Earth-based propellant over this decade and the next. So it's just something to think ahead about. And bringing all that together, I mean, what we did at Off-World, as we now have several robots in the field on full test campaigns. We have a autonomous digging robot that is undertaking operations in the first ore bodies. And we also have a very high power directed beam energy robot that just completed its first test campaign. And that is the results of that have just been completed. And I can't say that this is potentially a revolution in the mining sector, because of the let's say the strength of the rock reduction is very, very significant. And you can undertake these sorts of fractionated architectures and toolings when you have multiple robots working together. And we are expanding into several ore bodies and also into tunneling and construction operations with these robots. And as you start adding mining, excavation, processing, construction, fabrication, assembly, and manufacturing to this toolkit of capability across this universal platform, what we have is effectively the basis and the foundation for building civilization at any location in the solar system and ultimately beyond. And what you have here is a depiction of the operations architecture for our lunar ice mining deployments, where we're undertaking the excavation, the collection, the processing, separation, liquefaction, recondensation, and storage of liquid oxygen, liquid hydrogen directly from the lunar regolith. And so this is what we are now building upon for our lunar operations and our first program on the moon. And Off-World is likely either the first or one of the first companies to now have mining contract operations on 2 celestial bodies. So with that, I'll wrap up and say thank you very much for your attention, and look forward to the rest of the presentations. Thank you.
It's fantastic stuff, Jim. You know, you always have these arguments about should we send humans or should we send robots, and I've always said we're going to open up the solar system hand in claw. You know, we're going to work together.